Assalamu alaikum. Today we're going to talk about Avogadro's law. So the first thing is Avogadro's number. Avogadro's number. So the point is, if we have a container and this container contains gas, so there are particles here inside the container, and as we mentioned in the last time, whatever the kind of particles inside are or is, the distances here will be the same because it's an average distance. And the reason why this is an average distance, because the sizes of the particles are very, very small if compared to the whole size of the container. So we neglect their sizes and instead we calculate the mean distance and then we get this average distance. So Avogadro, the scientist, he found that in a 12-gram sample of carbon, because the molecular mass or the atomic mass of carbon is 12, the atomic mass of carbon is 12, so he got a sample of carbon, pure carbon, and he found that the number of atoms inside this sample equals 6.023 multiplied by 10 of power 23. So it's easy, 6.023 and here 10 to 3 again. So this number is called Avogadro's number because he discovered it, and it was set as a standard. So if we have, like, say 16 grams of oxygen or 14 grams of nitrogen. So in this case, this will also contain 6.023 times 10 of power 23 atoms of oxygen. The same thing for nitrogen. So if we say water vapor, like H2O, so what is the mass of this molecule? We have 2 hydrogen atoms multiplied by 1, which is the atomic mass of hydrogen, plus 16, so we get 18. So if we have 18 grams of water vapor, we'll find that it contains 6.023 times 10 of power 23 molecules. So it's a molecule here, not an atom. So this is the general idea of Avogadro's number. So by using this number, we can define something new, which is called the mole. So the mole is the amount of substance that contains 6.023 times 10 of power 23 atoms, molecules, particles, etc. according to the type of matter. And to calculate the mass of this mole, we use the atomic mass, the molecular mass, the particle mass, and so on. So if I want to calculate the mass of the mole, so the mass of a mole of oxygen. We all know that oxygen is found as a gas, and so it's a molecule of 2 oxygen atoms. So here the oxygen alone is 16 grams. So for the oxygen molecule, it will be 16 by 2, so 32 grams. So 32 grams of oxygen contains this number of molecules. And This is the mole. From the mole, we can finally describe what is Avogadro's law. So Avogadro's law states that any kind of gas found in a certain container, so if there are different gases and they are all in the same container, they will contain the same number of atoms or particles or molecules or so on under the same conditions. And by conditions we mean two things. We mean pressure and temperature. So it was found that at the pressure of 1 atmosphere and the temperature of 0 degrees Celsius, the volume of the mole was 22.4 liters. 22.4 liters. So if we have 1 mole of a substance, or its volume is 22.4 liters at 0 degrees Celsius and a pressure of 1 atmosphere, the number of the atoms or particles or molecules it will contain will equal Avogadro's number. So simply, there is the final thing that we are going to talk about, which is the density of the gas. So the density, rho, will equal, simply we know that the density equals the mass over the volume. So by knowing the mass of one molecule or atom or particle, we can calculate the density. So we know how many atoms or particles or molecules contained in a mole, which is of course Avogadro's number. So that's it. Then we multiply it by the relative mass. So if it's a molecular mass, we multiply it by the number. If it's an atomic mass, we multiply it. If it's a particle mass, we multiply it by the Avogadro's number and so on. And then we divided it by the volume. And in this case, it will be 22.4 liters. So this is how to get the density of the gas. I hope it was clear for you. And the next time we will know how to calculate the pressure of the gas. So until then, I thank you for watching and see you.